All right, so in our second lesson, we're going to be looking at measuring of segments. And all a segment is it's pretty much the same thing as a line, except it doesn't go on forever. Like a line goes on forever in all directions, a segment just stops. So we say that the distance between 2 points A and B is going to be written as, let's just say AB. So that's the distance that we have. I'm not going to give you two ways to remember it. We're just going to say that segment AB, like that, is written like this. And so we're looking at the distance that it covers. So how many spaces does this cover? Well, you see that's 1 space, 2 spaces, 3 spaces, and 4 spaces. So the length of AB here is 4, the distance between those 2 points. Okay, congruent segments. All right, so if AB is equal to CD, okay, if those are equal, then we can write this as AB is congruent to, and a special little symbol, it's got a squiggly line above the equal sign, and this sign right here means congruent. And all congruent means in geometry is that they're the exact same size and they're the same shape. So you can see here, this is a length of 1, 2, 3, 4. All right, so this has a length of 4. And then also AB has a length of 4. So since 4 is equal to 4, we can say that AB is equal to CD. Okay, and those would be able to go together. All right. Next thing, segment addition postulate. All right, kind of a funky name, but all it means is it's a segment addition rule. All right, so if A, B, and C are collinear, and B is between A and C, all right, so A, B, and C are on the same line, as you can see, and it says B is in between A and C. All that means is we can say AB plus BC is equal to AC. All right, so that's just saying this part plus this part is equal to the whole part. Okay, and kind of an easy way that I remember this as is I do part 1 plus part 2 is equal to the whole thing. Okay, so instead of saying it out as AB, BC equals AC and kind of getting confused and all that stuff, I just think of it as, hey, this is my first part, this is my second part. All right, part 1 plus part 2 is equal to that whole piece. Okay, so let's look at some examples of how we would use the segment addition postulate. All right, and all these examples says use the diagram below for questions 1 and 2. All right, so we have P, Q, and then R. All right, so number 1 tells us if PQ is equal to 9. All right, PQ is equal to 9, so I know that's 9. And QR is equal to 28. QR is 28. Okay, find the length of PR. And so PR is all the way across. So we're just going to use our rule. Part 1 plus part 2 is equal to the whole. All right, well, PQ happens to be our part 1. So we got 9 plus part 2 is my 28. And that's going to give us our whole. So if we say 9 plus 28, well, 28 plus 10 is 38, so we're at 37. So PR is equal to 37. Okay, let's look at another example that deals with this same diagram. All right, this time it says that QR is 17, and it says that PR, the whole thing, is 21. All right, and we're trying to figure out what that missing piece is. So that missing piece is part 1. So we don't know part 1. Plus part 2 is 17. And that's all equal to 21. Well, as you can see, you can probably just think of it in your head. You can say, oh, well, I know 4 plus 17 is equal to 21. All right, or you can solve it like you would any equation. Subtract 17 from both sides, and you get that part 1 could be x, whatever, that is equal to 4. All right, so PQ is equal to 4 based off of that reasoning. Okay, let's keep looking at our examples here. All right, it says if EG, okay, EG is 71, so EG is 71. That's my whole piece. All right, the whole thing is 71. Find the value of X. Well, now instead of just looking at only numbers, they give us a whole bunch of stuff for part 1. So part 1 and part 2. Well, let's just keep with our rule. Part 1 plus part 2 equals the whole. So we're going to say 8x minus 17 plus 5x minus 3 is equal to the whole piece of 71. All right, now this just goes back to being just like a Algebra 1 equation. All right, and we're going to have to solve this by combining some like terms. 8x plus 5x is going to give me 13x. All right, and then negative 17 minus 3, all right, is going to give me a negative 20, and all that is equal to 71. Okay, next step in our equation is going to be add 20 on both sides. Okay, when we do that, I'm going to come up here. We get that 13x equals 91. All right, and then we're just going to have to divide in our calculator. So take 91 divided by 13, and real simple, nice and easy, we get that x is equal to 7. Okay, so all we had to do was find the value of x, and so we have done that. We found that x is equal to 7. All right, moving on to number 4. So here, what information do we have? They say TV is 14x minus 8. And so we notice what? TV is the whole thing. So 14x minus 8 is the whole. All right, and so we have, this is part 1, 5 is part 2, and all that added together is equal to our 14x minus 8. So let's write all this out. 9x plus 2 plus part 2 is 5 is equal to the whole thing, 14x minus 8. All right, so take care of some like terms here. 2 plus 5, we get 9x plus 7 equals 14x minus 8. And now again, it just goes to solving an equation like we did in Algebra 1. So I'm going to decide to do subtraction 9x on both sides. We could do some other methods, but what is that going to give us? All right, I'm going to come over here. That's going to give me 7 equals 14 minus 9 is 5x minus 8. And so you know that we add 8 to both sides, do the opposite. 15 is equal to 5x. And I think that we'll see that when you divide by 5, you get that x is equal to 3. All right, so with x equal to 3, x equals 3, we're supposed to find TU. So what is TU? Well, I'm going to do this in blue. TU is this distance. It's 9x plus 2, but x is actually equal to 3. So we can plug this in and do 9 times 3 plus 2. All right, and actually find that distance when we plug x in. 9 times 3 is 27 plus 2, so TU is actually equal to 29. All right, so we can go from there and figure out what all these distances are. Okay, let's keep going. All right, number 5 says JL equals 5x plus 2. Find the length of JL. Well, again, that is our whole piece. JL, 5x plus 2. All right, so let's go through and let's try to solve that. Part 1 is 27 plus part 2 is 3x minus 1 equals a whole, which is 5x plus 2. We're going to combine our like terms. 27 minus 1, it's going to give us 3x plus 26 is equal to 5x plus 2. All right, and then I'm going to subtract 3x. Subtract 3x. We get 26 equals 2x plus 2. Subtract 2 from both sides. 24 equals 2x. And we get that x is equal to 12. All right, so x is equal to 12. It doesn't ask me to just find x. It tells me to figure out what all of JL is. So let's go back and plug 12 in for x. 5 times 12 is 60. 60 plus 2 gives me 62 is my final answer for what JL is actually equal to. Okay. Let's look at 6, number 6, CE. That is the whole is equal to 7x plus 4. So again, let's try to go through this one and solve it. So part 1 is x plus 3 plus part 2 is 8x minus 9 is equal to the whole 7x plus 4. All right. So if you want to, take a second, try this one on your own and see what you can get. All right. Okay, and after you work this out, like I already have done here, you're going to get that x is equal to 5. It only wanted us to get the value of x, so there's no need to go back and plug anything else in. Here on 13, 13 is going to be a great one for you to try on your own. Okay, so go ahead and try, excuse me, not number 13, number 7. Number 7 is going to be a great one for you to try on your own. So go ahead and do that, and we will discuss this as a class.